Now, let's begin with question number 6. Question number 6 is about light. 6a. Figure 6.1 shows a ray of light incident on the surface of a glass block. On figure 6.1, accurately draw the reflected ray. Before we draw the reflected ray, first we have to draw the normal line. The normal line must be drawn perpendicular to the surface of the glass block. So this must form a 90 degrees angle. After you draw the normal line, usually we draw normal line using a dashed line like this. Then measure the angle between the incident ray and the normal line. The angle is called the incident angle or angle of incidence. In reflection, the angle of incidence must be equal to the angle of reflection. So after you measure the angle of incidence here, make sure you use your protractor. Then measure another angle over here which exactly equal to this angle. After you measure the other angle, you can draw the reflected ray. And this angle is the angle of reflection equals to the angle of incidence. So the violet line here is the reflected ray. Question 6b. Figure 6.1 shows a ray of light incident on a glass prism. Put one tick only in each line of the table to indicate which of the angles labeled in figure 6.2 are the angle of incidence and the angle of refraction. Guys, this line is the incident ray and that line is the refracted ray. The angle of incidence is the angle between the incident ray and the normal line. So in this drawing, the angle represents by phi. So let's put tick angle of incidence on phi. Angle of refraction is the angle between the normal line and the refracted ray. So in this drawing, the angle represents by this, which is y. So let's put one tick on angle of refraction at y. This is the answer. Angle of incidence phi, angle of refraction y. Next question. The refractive index of water is 1.33. A ray of light passes from water into air. The angle of incidence at the water-air interface is 30 degrees. Calculate the angle of refraction. To calculate the angle of refraction, use this equation. N2 over N1 equals to sine I over sine R. I is the angle of incidence, R is the angle of refraction, N2 is the refractive index of the second medium, N1 is the refractive index of the first medium. The light passes from water into air. So air is the second medium and water is the first medium. Remember, the refractive index of air is 1. So N2 equals to 1 and N1 equals to 1.33 equals to sine of 30 degrees over sine R. This gives us sine R equals to 1.33 times sine of 30 degrees. Do the cross multiplication. Now, sine R equals to 1.33 times the value of sine 30 degrees equals to 0.5. You can use your calculator to find this value. Times 0.5. To find the value of R, use the inverse of the sine. So R equals to inverse sine of 1.33 times 0.5. Use your calculator. On the calculator, you have to type exactly like this. Don't forget the brackets. Then the answer is 41.68 degrees. Now guys, be careful. You have to consider the number of significant figure. The angle of incidence only consists of 2 significant figures. So, the answer should be round off into 41.7 or 42 degrees. You can use either answer because usually we can use one significant figure more than the significant figure used in the problem. So angle of refraction equals to 41.7 degrees or 42 degrees. The last question for number 6. Figure 6.3 shows rays of violet and red light incident on a prism. The dashed line shows the path taken by the ray of violet light in the prism. On figure 6.3, draw and label the path that the ray of red light takes in the prism. A calculation is not required. Guys, you have to know that red light and violet light have different wavelengths. Violet has less wavelength compared to red light. The smaller the wavelength, the further the light will be refracted from the normal line. Once again, the smaller the wavelength, the farther the light will be refracted from the normal line. So because violet has less wavelength compared to red light, the violet will be refracted farther from the normal line compared to the red light. Let's draw the normal line first. Remember, the normal line must form a perpendicular angle to the surface of the prism. So we know that the angle of refraction between the violet light and the normal line is this big. So for the red light, you have to draw it less than that. Make sure that the angle between the red light and the normal line is less than the angle formed by the normal line here and the violet light. So we get our red light as this one. It doesn't have to be exactly in this position. Just make sure that the angle between the red light and the normal line is less than the angle between the violet light and the normal line. In this slide, you will see how a prism can separate white light into its spectrum. As you can see here, the white light enters the prism. When the light comes out of the prism, it will be separated into different spectrum. Each color has different wavelengths. So each color will be refracted in different way by the prism. The separation of the white light into its spectrum is called the dispersion of light.